Thank you, Brandon, for that introduction. And I think I can remove this. You can all see my mandible. So I just want to give an extra shout out to Brandon. He really is, I'd say, the face behind the scenes of helping put this together, as well as several members of the board for the festival. We're working on this year-round. It doesn't just come up overnight. And also thank you to the Coconino Center of the Arts and Jonathan and the sound techs back there making this all happen. So if you're here, you brought your trowels, and you're ready to get dirty, this is not going to be a talk on gardening. I realized in the passport for this, it said how to grow more food with less water. Well, I added the geographic science here today, as there's more space for that today. So we're going to get a little nerdy and talk about some concepts here of how understanding geography, which is the science of where, is directly related to food and water security in the 21st century. I'd like to begin with a question. How can a map help feed the planet? That is a question that I ask in my research every day as a geographer. But before we get started, let's take a look at why this is important. Let's take a look at the Syrian civil war that happened in 2011 and is still not over. It is still ongoing. Just imagine if you are a farmer. You live in an agricultural community where your livelihood depends on you growing crops or raising livestock, and that's what you and your family have done for millennia. And then your country experiences the worst drought ever on record from 2006 to 2011. And you are faced with a choice. 75% of your crops have failed, 85% of livestock have died. What are you going to do? Stay there and starve, or try to go to the city and find work? And that's what millions of Syrian farmers found, the situation they found themselves in, is they had to move into cities. From this, in addition to other complex factors, this led to widespread civil strife and political discord that led to a war that was responsible for the deaths of over 500,000 people and the displacement of over 12 million people, with not a single person in the country who was not affected. And although there are other factors, analysts cannot deny the impact of drought that led to water scarcity, that led to food insecurity in this matter. But are water wars inevitable for the 21st century? I don't believe they have to be. I believe we can make choices today that will affect tomorrow. So a lot of these talks about environmental sciences and sustainability can get rather grim. But if you get one thing out of this talk today, I want you to know that there is hope, that we can make decisions today for a better world tomorrow. And this is not a new concept. The director of the World Bank, Dr. Ismail Sergeldin, said in 1995, if we don't start managing our water better, wars in the 21st century will be fought over water, in addition to several other major world leaders. And I have a quote on here. We have a quote, go back one. If we have a quote from Donald Trump and Kamala Harris on the same slide in agreement, I think that can put a silver lining that no matter what political spectrum you're on, we can all agree that water in the 21st century will be a critical issue and something that we need to address. So I am hopeful that this is something that can unite us and not divide us as we move forward into the 21st century. But let's first look at our civilization and how we are connected with water. Well, water first began around water. Civilization was founded around agriculture, around the fertile regions known as the Fertile Crescent, stretching from the Nile River through the Jordan River up to the Tigris and Euphrates River. This spawned ancient civilizations such as the ancient Egyptians, who built the Great Pyramids not far from the Nile River Delta. And we can take a look at our cities today. 90% of the world's population lives within 10 kilometers of a major body of water. 50% of that population lives within 3 kilometers. And just taking a look at the modern riverfront of Austin, Texas, with a photo from a friend who lives there, I added this just to show this thriving metropolis of a city that is being built up around this river. However, long before the Google building got there, anyone who's from the area might know Barton Springs, that this area has always been attractive to people just for its access to water. So water is an important, critical part of our culture, our humanity, and our society. For example, it mentions water in the Bible 722 times. That is more than hope, faith, worship, prayer, all of those words combined. From Islam to Judaism to Native American sayings and blessings, there is prayers for water, blessings for water, and understanding that water is not just critical for life, water is life. So it is something I believe that can unify us. Let's take a look at the water budget on Earth. We have a very small amount of it. And all the water on Earth is all the water we have, all that we're going to get. Humans have yet to figure out how to create more. So as an Earth scientist, I think this is a rather interesting concept, that water cannot be created or destroyed, it just changes shape and shifts form. So next time you have a glass of water, you can ponder, am I drinking recycled dinosaur pee? Maybe in some capacity you could be. But if we look at the Earth, about 97.5% of all that water is in the ocean. Salt water we can't drink and we can't grow crops with. That leaves only about 2.5% left of fresh water. And most of that is locked up in ice or groundwater, which is not usable to us. Groundwater is often known as fossil water, meaning because it can be extracted at a rate much greater than it can be recharged. So groundwater is not a sustainable solution for the future. So of that 2.5% that is fresh water, only about 1.2% of that is water that's on the surface that we can use. And of that, only about 0.5% is in rivers, and about 20% makes up lakes. And this map here just puts our water into perspective. This large sphere of water represents what all the water would look like on the Earth if it was put into one giant sphere over the United States. And the smaller, medium-sized sphere represents all of the fresh water combined. And the tiny little sphere that might be kind of over Georgia puts an emphasis to highlight just what is available in surface fresh water. So water is a very limited resource that we need to better understand. If you've been paying attention to the news lately, it might look like that we are facing a looming global water crisis. As water demand is increasing far greater than supply in the 21st century, how we manage and use our water is very important. Here is just a few news stories I gathered from over the summer. One interesting news story is just last month, for the first time ever, there was a shortage officially declared on the Colorado River. So limits will have to be put in place. And that is important to us here in Arizona, as 1 in 8 Americans depends on water from the Colorado River for their livelihood. So that's about 40 million Americans spanning from Los Angeles to San Diego to Phoenix to Las Vegas, all reliant on water from the most over-allocated river in the world. It doesn't even make it to its delta in Mexico anymore. We've completely dammed up an entire river. And as more and more people move to the southwest and there's more and more demand, that stress on the Colorado River watershed will only increase. So let's start to look at this from a global perspective. Where is our water going? Well, about 80 to 90% of all human water use goes to agriculture. And agriculture takes about 40% of the global land surface area. Furthermore, agriculture is responsible for about 30% of our greenhouse gases. But we can't just stop agriculture. We need agriculture. Life here depends on it. So in the world today, there is an urgent need to preserve environments and preserve biodiversity. And with these increasing demands, this leaves us with a global food and water security challenge. Over the next 30 years, the population is expected to increase from 7.9 billion today to about 10 billion by 2050. So how are we going to have enough water to feed all of these people? Where increasing cropland is not a solution, and allocating more water is also not a solution. So what we need is a new paradigm shift to increase efficiency in an environmentally friendly way. But you may be wondering, how did we get here? Well, we can thank the Green Revolution for that. And that is a phenomenon in agriculture that happened post-World War II that really took off in the 1950s and 60s. From major advancements in irrigation technology, cropland expansion with industrialization, and fertilizers, we were able to produce a lot more food. In fact, yields were increased by over 100%, which greatly increased the human population as well. However, many fertilizers can and do cause harm to the planet, and that is a different issue that will need to be addressed as we move forward. So why is there a problem all of a sudden? Well, that is because the limits of the green revolution have largely been reached in the 21st century. Cropland areas have rather stagnated, and the amount of water that can be allocated is diminishing. So we have a problem. What are we going to do in the 21st century for food and water? The good news is we have a solution. All that solution is we just need to create and inspire a blue revolution where we inspire taking water into account and having sustainability as a factor on how we go about agriculture in the 21st century. And this can be done through better cropland management with better technology for measuring, modeling, and monitoring of croplands, which what we as geographers do, therefore leading to making smart choices with food habits and waste habits so we can grow more food with existing croplands and less water allocations. So you may be wondering, what can we do? Well, I'll look at this on an individual scale and also on a global scale. We maybe have seen the signs in our hotel rooms that say if you use less towels, you can help save water. So that's one way. I think it's good to highlight that. Another way, I was down in Sedona recently, and I have a friend that makes crystal pyramids called organite. And on the list of things he says they can do, one is that it helps plants grow better and require less water. So I was thinking, I work as a geographer professionally for a living, working on this. What am I doing in my personal life? So I had to get one, and that may or may not be me charging it up in the moonlight. But in addition to that, there are other practical solutions that we can do. I want to bring up the concept of water footprint. And some of us may have heard of carbon footprint. Water footprint is the implication that every choice we make, every product we consume, every food we eat, consumes water. And if we can understand how much water we are using, we can help to make better choices. On this website, waterfootprint.org, you can calculate your water footprint. And I calculated mine. You just enter some basic information about your lifestyle. I was astonished to find out that I consume about 1,500 gallons a day just for what I thought was a fairly modest lifestyle. And from this map, you can see that the United States has the highest water footprint per capita of anywhere on Earth. So look on the bright side of that. That means we have the most room for improvement. And we can improve by making conscious choices. And this here shows a chart just of the foods we eat and the impact that has on water. For example, one steak consumes approximately 700 gallons of water. One half-pound hamburger takes about 50 bathtubs worth of water, moving down to a salad that only takes about 21 gallons of water. And there are choices that we can make with comparisons. For example, if you're going out celebrating these talks later tonight, a glass of beer takes much less water to produce than a glass of wine. Or it takes much less water to produce a cup of tea than a cup of coffee. So these are just things I want people to be aware of and make their own personal choices. I'm not here to tell people what to eat and what not to eat. However, plant-based diets do consume significantly less water than animal-based diets. But one thing I think that we can all agree on is to focus on reducing waste. About 30 to 40% of all food in this country is wasted. That's about 133 billion pounds and $161 billion worth of food in 2010. It also comprises the largest category in landfills. So I'd just like to think about if we could use that energy, that labor, that water, and put it back into other sources, it could help change some of this direction we're heading, just from individual choices that we can make. Now I'm going to get to the exciting part, where we're going to talk about crop water productivity, what I study as a geographer. And this is a ratio of how much water crops use in order to produce a certain mass of food, listed in kilograms per meter squared. It is also known as crop per drop. This is important because once we can monitor and measure and model something, then we can begin to manage it and pinpoint areas on Earth where there's room to improve and figure out areas that are doing well and help determine why that is. I'll talk about two different methods, one using a global geospatial analysis and one that is currently ongoing where we are looking at trying to assess crop water productivity at the individual field level. The first study here represented a global analysis using Geographic Information Systems, known as GIS, which is a digital mapping program. And with this, I compiled all of the crop water productivity studies I could find, and I put them on a map. And then I combined that with comparing to geospatial variables of soil, climate, and latitude. From this study, we did determine different soil and latitude zones and climate zones where crops use water more efficiently. But the most impactful insight was from this is that we found within arable lands, crops tend to use water more efficiently at higher latitudes. So that can be very important information for future water managers to utilize in the years and decades to come. And I like to provide a little potential why we should save water. I think when you're trying to motivate people for change, it's always better to go with encouragement over criticism. So one good thing about this study was we could determine how much water was being used or estimate it for a given region. So for example, in the United States, if we could increase the crop water productivity of wheat by just 10% in a given year, that would save about 5,000 billion liters of water. To put that in something we can understand more here in Flagstaff, that would be about 1,900 worth water volumes of Lake Mary. And there are many ways that crop water productivity can be improved that I won't go into too much detail here, but they kind of depend on an individual case-by-case basis. So we first need to understand where they are, and then we can focus on things like increasing water delivery, managing how systems crops are planted in, land leveling, recycling water, modernizing and optimizing irrigation systems, and applying deficit irrigation in dry areas. The next study involves remote sensing analysis. This is something geographers do when you're looking at information from a distance, hence remote sensing. And here we're going to talk about satellite images and what we can do with them. So first, I selected a study area in the Central Valley of California, also known as the produce basket of the United States, responsible for producing most of our fruits, vegetables, and orchard crops. And then using the thermal band from a satellite image, as satellites can detect frequencies and spectrums of the electromagnetic spectrum that our eyes can't, we can look at that infrared information and produce a map that shows evapotranspiration by combining that with other meteorological data. With that map of evapotranspiration, which is showing how much water is evaporating from the surface, I can overlay that with a map of where crops are grown up here and pick out individual crops, and I can produce a water use map giving the known area. From that, I can combine that with agricultural statistics that are published in California, and I can determine a yield to therefore determine crop water productivity, which can be mapped at high spatial and temporal resolutions. And to just put an example of how much water could be saved if we could increase crop water productivity, just in this little individual study site in one growing season, that was about 438 square miles, which for reference, that would fit about 6 or 7 greater Flagstaff areas within that. From all of the almonds grown in that area, we determined that it took about 1.5 gallons of water to produce one single almond kernel. And yes, you did hear me correctly. 1.5 gallons of water per one almond. And that number is within reason from other published studies that are out there. This is the equivalent to about 66,000 Olympic swimming pools. And then to put that in perspective, if we could increase crop water productivity for almonds just in this one study area by 10%, that could save almost 600 Lincoln Memorial reflecting ponds worth of water. An interesting note on this, another study looked at how almonds were grown in the northern Central Valley in more humid climates, and there they determined almonds took about 3 gallons of water to produce one almond. So that's interesting insight for future water managers to look at where the same crop grown in different areas, how it uses water more efficiently. And with that, I can wrap up with a language that I think we can all understand here, emojis. So applying the science of geography with GIS and remote sensing can lead to making more informed decisions for sustaining our ecosystems and ensuring food and water security as preconditions for human advancement and welfare. To translate that, as more and more people are going to be on the planet consuming more resources, we can use geographic science to make more informed decisions about how water is used, which can lead to farmers growing more food with less water. And that is how a map can help feed the planet. Thank you.
Really well done.
Thank you, Brendan.
So I forgot one part in the intro. I was supposed to say that Danny's got a real thirst for knowledge.
Very true.
These things crack me up. Okay, a more serious question.
Yes.
Earlier in the talk, you mentioned that the Earth has of the water, 2.5% is fresh water. Mm-hmm. In really arid countries, it's common to do desalination, to pull water from the ocean and use that for crops, for water usage, for whatnot. Is that a legitimate answer to some of the problems that you posed, or does that have its own flaws?
I would say, first of all, great question. It is not a silver bullet solve all the problems. It is one way to improve. However, using desalination is very energy intensive, so you can actually consume more carbon resources to produce that water. And also, it leaves the problem of waste. What are we going to do with all the salt left behind? So I think desalination is a good thing, but is more of a temporary solution, and the whole world cannot depend on desalination, at least not with the current technology we have.
All right. Thank you, Danny.
You're welcome.
Another round of applause, please.
Thank you.